The James Webb Space Telescope has made a truly extraordinary discovery, one that has captured the imagination of scientists and the public alike. For the first time, the telescope detected beams of light radiating from what appears to be an urbanized region on a planet located millions of light-years away. These beams don't resemble natural phenomena such as auroras, lightning, or volcanic activity. Instead, they mirror the organized glow of artificial lighting, something akin to a city at night. What makes this even more astonishing is the source, a location millions of light-years from Earth. These mysterious lights seem to be emerging from Proxima Centauri b, the closest known exoplanet beyond our solar system. This planet orbits the red dwarf star Proxima Centauri, just over 4 light-years away. The bursts of light observed on Proxima Centauri b do not conform to any known natural processes. This enigmatic discovery has reignited global curiosity about the possibility of alien civilizations existing beyond our tiny blue planet. For decades, both the scientific community and curious minds across the world have speculated about life beyond Earth. The idea that we might not be alone in the universe has fueled countless theories, movies, books, and research missions. But now, with this compelling evidence, the James Webb Space Telescope may have taken us one step closer to finding out the truth. This finding marks a significant milestone in the search for extraterrestrial life. As the telescope scanned the distant reaches of space, it captured these unusual light patterns from Proxima Centauri b, patterns that strikingly resemble the glow of city lights seen on Earth from space. The resemblance has led many researchers to wonder, could this be an alien metropolis shining across the cosmos? If this theory proves accurate, it would revolutionize our understanding of the universe. It would mean that intelligent civilizations not only exist but are capable of generating artificial light sources, perhaps even cities, just as we do on Earth. The implications would be enormous, philosophically, scientifically, and technologically. It would mean we're not alone. This discovery didn't happen overnight. It's the result of years of planning, technological advancement, and scientific collaboration. The light signals were detected from a distance of over 4 light-years, an astonishing feat. NASA engineers and astrophysicists are now analyzing how long these signals might have been traveling through space, possibly waiting for our instruments to evolve enough to detect them. David Kipping, an astronomer at Columbia University, emphasized the uniqueness of the planet. He pointed out that unlike many rocky exoplanets that absorb sunlight and re-emit it as infrared radiation, Proxima Centauri b shows a pattern that is different. This could be due to its special orbital and atmospheric relationship with its host star, Proxima Centauri. The James Webb Space Telescope's ability to detect and interpret this behavior is helping scientists dig deeper into how exoplanets function, and perhaps thrive. The telescope's infrared capabilities are a major reason for this success. Webb is especially sensitive to infrared wavelengths, allowing it to detect even the faintest glimmers of light from far-off worlds, even during their night cycles. While older telescopes struggle to perceive such dim signals, Webb excels. This allows scientists to confirm whether the alleged city lights on the dark side of Proxima Centauri b are indeed artificial. What makes this observation stand out is that artificial light from a civilization must fall within a narrow frequency band, quite different from the broader wavelengths emitted by stars. If the telescope has truly picked up such light, it could signify energy usage, structured planning, and intelligent life. The planet's interaction with its star also leads to dramatic temperature swings. During the day, the planet could become blisteringly hot, while nights might drop to frigid lows. These extremes suggest that if life exists there, it must be incredibly adaptive, or perhaps living in controlled environments like cities. The variations in temperature are key indicators of the planet's composition. If Proxima Centauri b has an atmosphere, one side could be a scorched desert, while the other side is cloaked in icy darkness. This kind of temperature disparity also provides clues about the planet's atmosphere. The James Webb Space Telescope can observe thermal emissions, which help astronomers understand the heat distribution and therefore the potential for life. Interestingly, the orbital path of the James Webb Telescope allows it to maintain a consistent alignment with Proxima Centauri b's orbit, which is about 11.2 Earth days long. This alignment enables continuous observation during critical periods such as sunrise and sunset on the planet, ideal times to detect atmospheric changes. As the telescope gathers more data, researchers aim to determine whether Proxima Centauri b has an atmosphere and what elements it contains. Finding gases like oxygen, water vapor, methane, or ozone would be an extraordinary sign. These are considered biosignatures, chemical indicators that life might be present. While the James Webb Telescope can efficiently identify molecules such as carbon dioxide, methane, and water vapor, it has limitations when it comes to free oxygen. Nonetheless, ozone, which stems from oxygen, could offer a promising alternative clue. Despite its incredible capabilities, Webb can only observe a limited number of exoplanets in close proximity to Earth. That's why ground-based observatories, like the upcoming Extremely Large Telescope, ELT, set to begin operations in 2027, will play a vital role. The ELT will provide high-resolution observations of planetary atmospheres, complementing Webb's work by examining the finer details of distant exoplanets. But even more advanced technologies are on the horizon. Future telescopes are being designed to directly block out the overwhelming brightness of stars, which often drowns out the faint light from orbiting planets. Imagine trying to spot a firefly next to a floodlight. This is the challenge astronomers face. Tools like the coronagraph and the starshade are being developed to solve this. A coronagraph works from within the telescope, blocking out the star's light and allowing scientists to view the much dimmer light reflected off the planet. The starshade, on the other hand, is a flower-shaped spacecraft that flies in front of a telescope, thousands of kilometers away, to block starlight before it even enters the telescope lens. This method allows for a clearer view of exoplanets in the habitable zone, the region around a star where conditions might allow liquid water, and potentially life, to exist. These technologies demand incredible precision. A starshade must align to within fractions of a millimeter across vast distances in space. Engineering challenges include creating devices that are small and light enough to launch, while being strong enough to survive the extreme conditions of space. Yet the scientific potential is monumental. Successfully observing an exoplanet's atmosphere could lead to the discovery of biosignatures, chemical indicators that biological processes are occurring. There's also a growing interest in developing space telescopes that can directly image the surfaces of exoplanets. This would involve adaptive optics, technologies that correct for distortions in telescope images due to atmospheric interference or mechanical movement. Combining adaptive optics with starlight blocking techniques would allow scientists to not just detect planets but map their terrains, track their weather systems, and study their climates in real time. Such breakthroughs would represent a new frontier in our ability to assess the habitability of distant worlds. The discoveries we make in the coming years could completely transform our understanding of life beyond Earth. The future of space exploration is racing forward faster than ever. With each observation, the James Webb Space Telescope is unraveling cosmic secrets, peering deeper into the universe, and perhaps even spotting signs of intelligence that have existed light years away all along. The discovery of potential SETI-like lights on Proxima Centauri b may mark a historic turning point. It might be the first real hint that we are not alone in this vast and mysterious universe. As humanity stands on the edge of this cosmic revelation, one thing becomes clear: this is only the beginning. The search for extraterrestrial life continues with more purpose, curiosity, and technological firepower than ever before. Stay with Waves Discovery as we journey deeper into the stars.